Hey Algebra 2 students, this is our video for in class on Thursday. I'm out at the math day in Lincoln, and so this is going to take you through a couple of examples to continue seeing patterns that you can look for when solving three variable systems of equations. So remember, I'm not checking last night's homework until tomorrow, so if there are any problems that you didn't have a chance to finish last night, this is another opportunity to see how to approach those problems and to practice them this evening because you won't have too many new ones to take home today as well. So we're going to go ahead and start off with a substitution review problem, and then we'll circle around and continue to practice with elimination as well. So this first problem, warm-up example number 1, we're going to take a look at the same process that we started off with yesterday and how we can solve for one variable completely by itself to use to plug into remaining variables. So let's go ahead and do that together with this first x minus 2y plus 3z equals 22, that particular problem. So what we want to get started on here is to get x completely by itself in this expression. So to do that, I'm going to add over the 2y and the 3z so that I have 22 plus 2y minus 3z as my expression for x. Now I'm going to take that x and I'm going to substitute it in here and here, so that way I have two equations that will only have y and z. So I like to label my equations A, B, and C, so I know what I'm substituting in. So I'm going to start off with equation B, and I'm going to replace the x with the expression that we found right here. So we'll have 2, and then this x will become 22 plus 2y minus 3z, and then in this expression I also have minus 3y minus z is equal to 5, so all from equation B. Now I'm going to go ahead and distribute and combine like terms, so I'm working with an equation that just has y and z in it. So when I multiply the 2 in, this will become 44 plus the 2 times 2y becomes 4y, and then the 2 times minus 3z is going to become minus 6z. Then I have minus 3y minus z that were already there, and that's all equal to 5. From there, I just want to combine like terms. So I have a 4y and a minus 3y, so that means I'm going to have 1y. And then I have a minus 6z and minus 1 more z, so this will become minus 7z. So I combined this y and this y to get to the 1, and then the negative 6 and the negative 1 becomes the negative 7. At that point, I'm going to need to subtract 44 from both sides so I can combine my constants. So over here, I'll have 5 minus 44. Now 5, if I subtract 44 away from that, is going to give me negative 39. So I end up with y minus 7z equals 39. And just like we did yesterday, we want to hang on to this expression for a second because we want to do the substitution step with the next equation down. So that way we end up with two equations, both with just two variables. So we'll come down to equation C, and we'll have 3, but this time instead of the x here, we'll have 22, that whole thing that we solved for x, 22 plus 2y minus 3z, and then we have a plus y, a minus 5z, and that's all equal to negative 32. So once again, I want to distribute and combine like terms. 3 times 22 is going to give me 66. 3 times 2y is going to give me plus 6y. 3 times negative 3z gives me negative 9z. Then I have plus y minus 5z is equal to negative 32. So then when I combine my y's, 6y plus y gives me 7y, and then minus 9z minus 5 more z's is going to give me negative 14z. So I combined my y's, and then I combined my z's. Then I just need to combine my constants. So I'm going to subtract this 62 over here, and when I have negative 32 and I subtract 66 more, this whole expression becomes equal to negative 98. So then I get to go ahead and box that up. So at this point, I have two new equations each one just has a y and a z in it, which is nice because then I can go ahead and use substitution or I can use elimination. So let's go ahead and write those down next to each other. I have y minus 7z is equal to negative 39. That's this equation here. And then I have 7y minus 14z is equal to negative 98. That's this equation right here. So I'm going to go ahead and use elimination to get variables that I can cancel out here. Notice how I've got a 1y up top and a 7y down below. So if I multiply all of my terms by 7, I'll be able to cancel things out. This expression, I can make a 7y. Then this can become a minus 49z if I multiply 7 by 7. And then I'm going to get a little bit of a big number over here because I'll have negative 39 times 7. So I'm using my calculator for that, but it gives me negative 273. So at that point, I can go ahead and combine terms. Because my 7y's are both positive, I need to subtract in order to be able to get things to cancel. So 7y minus 7y, that's all going to go away. Then I have negative 49 minus negative 14. Anytime I'm subtracting a negative, I'm really adding. So negative 49 plus 14 gives me negative 35z as my final answer there. And then over on the right-hand side, negative 273 minus negative 98. That's the same thing as negative 273 plus 98, which gives me a value of negative 175. At that point, I can divide both sides by negative 35, divide by negative 35. And when I do that, when I take negative 175 and divide by negative 35, the value that I get out from my calculator is 5. So my z is just equal to 5. From there, I can go ahead and substitute back in to solve for x and for y. So we found this expression. I'm going to go ahead and take this z right here, and I'm going to plug it in to this equation, so that way I can solve for y. So I'll have y minus 7z is equal to negative 39. Y minus, we found that z was 5, is equal to negative 39. If I multiply, y minus 35 equals negative 39. And then I can add 35 to both sides. And when I do that, I get that y is equal to negative 4. From there, I've got a z and I've got a y. So then it's up to me to pick the equation I want to solve back into for x. But this equation up top already has x completely by itself on one side. So I would recommend using this one and showing that x is equal to 22 plus 2 times my y value is negative 4 minus 3 times my z value is 5. So this will become x is equal to 22 and then 2 times negative 4 minus 8 minus 3 times 5, so minus 15. So when we plug this all back in, 22 minus 8 minus 15, I end up with a value of x is equal to negative 1. So that's how we can solve a 3-variable system fully using the substitution process. And remember, you can report your final answer as what we call an ordered triple, which just means you write out x comma y comma z. In this case, that will be negative 1 comma negative 4 comma 5 for my x, y, and z values. And that's my final answer, so I can go ahead and box that up. And we're all done with that example. So we're going to go ahead and move forward now in our next video to talk about how we can take on these kinds of problems with elimination being our first step instead of substitution. So go ahead and open up that next video to see what that process is going to look like.